We're gonna open that up a little bit. I might need to get another sheep brain, yeah. Hey, can one of you see if we can find a pineal gland on a mid-sagittal cut on some of the sheep brains that are already out? This one doesn't, none of these have it. Okay, first thing we need to talk about, meninges. Meninges are the outer coverings of the brain. There are actually 3 layers to it. You've probably heard of meningitis. The meningitis is the inflammation of those meninges. So the first one, as you can see, is the outer layer. The outer layer is called the dura mater, and that's, you can see a little bit still attached here. Awesome, thank you. So this right here, this is dura mater, and this was actually supposed to set up right about like that. But this thick layer, it's opaque. This opaque layer here, opaque means you can't see through it, whereas translucent or transparent means you can see through it. This opaque layer right here is the dura mater. Dura mater basically means durable mother or tough mother. Okay, so that's it right there. Next layer is the arachnoid layer. Now the arachnoid layer is found in all of these brains. Okay, and the reason why I know that is if you can see any blood vessels at all, you can't see down into the these little divots here, then you know it's still attached. Now the arachnoid layer is named after the word arachnoid, which comes from what? Spider, right? You saw Arachnophobia with Jeff Daniels. That's your homework tonight. Come back with a movie line. So these are the, if you see vessels on the surface, you know it still has the arachnoid layer attached. Now what is why is it called arachnoid layer? This layer right here is almost, I liken it to cellophane. If you put cellophane on the surface of this, it's going to kind of go over the surfaces of these little bumps and crevices, but it's not going to go all the way down inside of them, right? Now, what sits underneath this arachnoid layer is cerebrospinal fluid, the fluid that goes around the outside of the brain, and spinal cord as well. What happens is that cerebrospinal fluid underneath this layer will cause it to tent upward, to push upward, almost like a kind of balloons upward. And then the arachnoid layer, or the arachnoid name that we give, are actually the little tendrils. This layer is up here. They're little tendrils that kind of go down and attach to the deeper layer. So the dura is up here, the arachnoid layer's here, and these little tendrils that stick down and look a lot like a spider web. Okay? And we'll show you that in lab on, no, not in lab, in lecture on Tuesday. Okay? So it sticks down like this, and it attaches kind of like guide wires, attaches to the deeper layer so it doesn't tent up too much. So this is the arachnoid layer, and then where the CSF is, cerebrospinal fluid down here, is called the below arachnoid space. Okay? And then the last layer follows, it's the one that's deepest. It follows all the nooks and crannies. It's below this layer here that you can actually see. It's called the pia mater. Pia mater means tough mother. Pia mater means delicate mother. Okay? So delicate mother follows all these little nooks and crannies down in the deep crevices that you can't see because the arachnoid layer is kind of tinting over the top of it. Okay? How are we doing so far? All right, next thing is longitudinal fissure. So if you look right here, longitudinal fissure goes between the 2 left and right halves of the cerebrum. This is cerebrum here, cerebellum back here. So then the next thing are the convolutions. Now, these are the convolutions, all these hills and valleys that you see. Collectively, they're called the convolutions. Individually, all the hills are called gyri. And then these depressions in between the gyri are called sulci. So the hills are gyri, the sulci are the valleys. Okay? Cerebrum. Cerebrum here. Okay? Cerebral hemisphere would be 1/2 and the other half. Cerebellum is back here. This is the cerebellum. What I'd like to do on a side view of the cerebellum, now this is a mid-sagittal cut. This is also a mid-sagittal cut. What we will not do is, because there are some of these, we have cuts like this through the brain, we will not put those on the test. You'll only see this type of presentation and a presentation like this. Okay? Full brain or mid-sagittal cut. What I'd like to show you here with the cerebellum is this thing right here. It looks like a little bush, doesn't it? It's called the arbor vitae, which means tree of life. See a little bush right there? Okay, arbor vitae, tree of life. Alrighty? Next thing you've got cerebellum. You have corpora quadrigemina. Corpora means body. means many, means multiple bodies, and quadrigemina means four. So if you look here, this is the corpora quadrigemina. See the four bodies there, bump, 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 bump. The two upper ones are called the superior colliculi, and they look like, kind of like, look like butt cheeks. Okay? Right there. Okay? Two superior colliculi, two inferior colliculi. Two superior colliculi, two inferior colliculi. Did you see it too, Gabby? Okay. Jasmine, you saw it? By the way, these two little things are involved in automatic reflexes. And we'll talk about this in the lecture maybe another time or two. But they're part of what we call the tectospinal reflex. So I did this on Tuesday, which was Halloween, so it was perfect. So I always tell students, you know, let's say you went to Halloween 17, the movie, and you came back and you were scared out of your mind, but your little brother knew that you went. So he was hiding in your bedroom when you got home. So as you open the door, you see the shadow move across, and then you hear this boo. So you saw the shadow and you heard the boo. The superior colliculi are involved in that reflex of actually, before you ever really know what's going on, protecting yourself. So the superior colliculi are involved in that sight reflex, seeing the shadow, and the inferior colliculi are involved in the hearing reflex, hearing him yell whatever he yells at you. Okay? We'll talk about the tectospinal reflex a little bit later on. But those are that's the corpora quadrigemina, the two superior and inferior colliculi. Superior larger. Next thing, olfactory bulbs. Okay, so we fold this over here and you can see olfactory bulb there, and olfactory bulb's kind of been broken off there. Let's see if we can see it better on another sheep brain. This is probably a little bit better. No, it's cut off. This one's still intact. Olfactory bulb there, and then that one's broken off right there. See if we can see it on any of these dudes. Sometimes they're there. Here's olfactory bulb right there. See it? Pretty straightforward. Optic nerve. Now, the optic nerve is the nerve for the eyeballs. Now, the problem with these sheep brains is they cut the optic nerve so close to the base, to the brain, that you don't see the nerves themselves. See if I see a good one. This is a little bit better. You can see the nerve kind of coming off there a little bit. And then this center region right here where the nerve, so you got an eyeball out here, eyeball out there, and then the optic nerve goes over the eyeball, optic nerve goes to the eyeball. And then where it meets in the midline, this area right here, almost looks like a cross. When everything's the way it should be, you got a nerve coming back here, a nerve coming back here, meets in the middle, and then this thing is the optic tract coming back here and here, and it looks like an X. So in the center of the X, we call that area, the center of the X right there, we call that the optic chiasm. Optic chiasm here, optic tract back here, and optic nerve comes off there and there. So optic nerve, optic chiasm in the middle, across to the X, and then this is going to be the optic tract back here and optic tract back there. Optic tract here, optic tract right there. Okay? Optic tract here, optic tract right there. Let's see. And so here's the other thing I want, Gabby, let's open up your lab manual for me. And I don't know what chapter. We're going to be exercise 19. So go to, it'll say exercise 19 at the top somewhere. No, go where you were going. Actually, no, go back. Keep going back. I think I saw something. All right, so I don't know what it is. That's 17. Okay, so go back one more page for me. All right, that page right there. What page is that on your right-hand side? Right-hand side. What page? Yeah, what page you have right there?
293.
293. Okay, so stay right there for me. So the top one is a photograph. The bottom one is is artist rendition. Okay. Those are the 12 cranial nerves. The TAs have written the little mnemonic up there on Olympus Tower and top fit in German view to hop. That is a way to memorize those. So here's what we will do for lab. The lab test. On the sheep brain proper, like the picture you have up above, we will test you on either the olfactory or the optic on the sheep brain. But here's the problem. The TAs in the past are like, oh, that's a great trigeminal. We need to do trigeminal. So they put a pin in the trigeminal. You guys start moving around, and these things will dry out pretty quickly. And those little thin, almost feather-like looking little nerves, get broken off. So then we got to re-tag it, just makes it a pain in the rear. So what you need to know for the lab test is on the sheep brain, on this right here, you need to know cranial nerve 1, that's olfactory, cranial nerve 2, which is the optic. Cranial nerve 3 through 12, you've got to know on a picture like that. I promise you, we will not do a photograph, we will do a drawing like the one you have down below. I've got some other textbooks, but they will be drawings. And they're pretty easy. You go from the top or the front to the bottom or the back. First cranial nerve is towards the front, 12th cranial nerve is towards the back. Okay? So just memorize those, and you should be good. So that's the way we'll do those. So I'm not going to go over each one right now. We covered olfactory bulb, we covered optic nerve, we covered optic chiasm, we covered optic tracts, and then later on you're going to see there's a bunch of nerves in here that we won't have you know. The next thing we want to go to is the hypothalamus. And the hypothalamus is below the thalamus. Hypo, below the thalamus. So let's see if we have a good shot of hypothalamus. This one's not too, it's about broken. Alright, this one's not too bad. See this circular region right here? Can you all see that circular region right there? Okay, Christina, you see that? Okay. And you see that circular region right there? This is the what we call the intermediate mass of the thalamus. Intermediate mass of the thalamus right there. Intermediate mass of the thalamus. Intermediate mass of the thalamus. The circle down below is the optic chiasm. Well, we cut through the middle of the brain, so the optic chiasm was where the optic nerve crosses. Are we good? Optic chiasm. Optic chiasm. Optic chiasm. Okay? Intermediate mass of the thalamus, optic chiasm. So where would the hypothalamus be setting? Well, it's going to set below the thalamus. This is thalamus, but above the optic chiasm. So this is the hypothalamic tissue. Below intermediate mass, above the optic chiasm. This is hypothalamic tissue. Adeline, there's intermediate mass of the thalamus. This is optic chiasm. Below the intermediate mass of the thalamus, this is the hypothalamic tissue right there between those two, between this and between that. Alrighty? So, hypothalamus, you got this thing called the infundibulum and mammillary body, so you won't be able to see that from this perspective very well. You'll see it better from this perspective. So here's your optic chiasm. Hypothalamus is down in this area right here. Okay? And then these, by the way, are the trigeminal nerves. See how look small they are? And these are big, relatively big nerves, but they're still very small and very fragile. So optic chiasm, okay, and then the hypothalamus is in here, and then this right here is called these are called the mammillary bodies. Same thing if we pull this back. Here's optic chiasm. This is mammillary body right there. Why do they call it mammillary body? Well, in sheep you can't really tell, but in humans, there's actually two bulbs that set here on both sides, and they look like small breasts, so hence the term mammillary body. This is where the infundibulum is. It's the stalk that connects the pituitary gland. And by the way, the pituitary gland is this right here. That's pituitary gland. But here's the problem. It sets in the dura mater. Remember, this is the dura, the tough mother, the opaque or non-seeing through layer, right? That was dura mater there. So this is pituitary gland right here. So when we pull the dura mater back, we pop the pituitary gland off of the infundibulum, which is where it sets right here. Infundibulum basically means stalk. It connects the pituitary gland to the base of the brain right here. And this infundibulum has been removed on this one, so you no longer see it. You can still see a little bit here. You can't see it there. Alrighty? So, that's infundibulum, mammillary body, hypothalamus. Now we'll go to the ventricles a little bit later on. Cerebral peduncle. That's kind of a funny name, isn't it? Peduncle or peduncle. So the peduncle or cerebral peduncle is the way I like to do this. TAs have heard me say this. It's like broccoli or cauliflower. You've got the floret at the top, which is where the round thing is, and at the bottom is the stalk, right? So this is the floret, the round thing. This would be the head of the broccoli. And then the stalk is this area right here that comes down. So the cerebral peduncle is this area here and here. It's also this area here and here, okay? And then this area here, you can't see the other side. But what you'll notice is this cerebral peduncle is the front part of what we call the midbrain. Now the midbrain is part of the brain stem. So this here is cerebrum, this back here is cerebellum, and then all this area in here, this area down to here, this is all part of the brain stem, because it's the stem of the brain. It would still be part of what would kind of look like that stalk that we talked about. But this, so let's divide the brain stem up if we could. See so when the brain's laying like this, see the highest part of the brain stem, see that area right there, that bulge? Let's get our bearings. That bulge right there is called the pons. It's the highest part, okay, laying on its back. Same thing if we even lay this one on its back. The highest part right there is the pons. Pons, by the way, means bridge. Okay, so the pons is in the middle. The pons is in the middle. The pons is in the middle. So what's the brainstem above the pons? Well, these are the cerebropeduncle. They're part of the midbrain. So midbrain, pons, and then this area, this is the cord down below. But from here to here, see how it's wider than the cord? Pons right there. This area is called the medulla oblongata. Hakuna Matata. Okay? So midbrain, where the cerebropeduncle is, pons, the highest part, medulla oblongata between the pons and the spinal cord. Is that good? Brittany, are we good? All right. Let's see, cerebral peduncles, we already said those were these areas. Look like the front of the stalk, with this being the floret of the broccoli. So then you got a bunch of nerves here. Oculomotor nerve, trochlear nerve. We talked about pons, we talked about medulla oblongata. Trigeminal nerve, abducens nerve, facial nerve, vestibulocochlear nerve, accessory nerve, hypoglossal nerve. Those are all nerves that you need to know from what? The artist rendition, the picture down below. All right? All right, so now we want to go to internal structures. We talk about the corpus callosum or corpus callosum. That's not too bad. Okay. In order to talk about the corpus callosum and the fornix, we need to talk about the ventricle. A ventricle is a space inside the brain. Okay? Does that look like a space inside the brain to y'all over there? Okay? Does that look like a space inside the brain? Okay? How about that right there? Look like a space? This is called the lateral ventricle, of which there are two. One inside of each of these cerebral hemispheres. Lateral ventricle on the right, lateral ventricle on the left, 1, 2. Which one's 1, which one's 2, it doesn't matter. There's two of them. Okay? So when we look at that, I like to say that looks like the mouth. Does it look like a mouth? Okay? Do you see the upper lip right there? Do you see the lower lip right there? See the upper lip? The lower lip? The upper lip is the corpus callosum. The lower lip is what we call the fornix. That's this thing right here. I have a little saying, this is my little saying, but the fornix connects the hippo to the hypo, okay? The fornix connects the hippocampus to the hypothalamus. It's just nothing but projection fibers. Remember we talked about the, what did we talk about? We talked about the, we're looking at the brain, talked about the switchboard. Well, these would be a bunch of wires in that switchboard going from one area to another area, okay? So upper lip, corpus callosum. Okay, lower lip is the fornix. By the way, the corpus callosum are projection fibers as well, connecting the left and right hemispheres of the cerebrum. Okay? All right? So we got corpus callosum right there. Lateral ventricle, we just did that. Fornix, we just did that, the lower lip. Upper lip, corpus callosum, lower lip, fornix. Mouth in the middle, lateral ventricle. Now we want to go to third ventricle. So 1 and 2, now we want to go to the third one. Let's go back to that one that I was showing y'all. This is the one, we can use this one. This is, we'll use this one, probably better. So remember we said this is the intermediate mass of the thalamus? We said this is the optic chiasm. Intermediate mass of the thalamus, optic chiasm. We said hypothalamus is right here. Intermediate mass of the thalamus, optic chiasm, and hypothalamus was right there, correct? Well, it just so happens that the third ventricle is where the hypothalamus is. say it again. Third ventricle is where the hypothalamus is. You say, well, Dr. Simpson, how can the third ventricle and the hypothalamus be the same thing? Because the hypothalamus is tissue. The third ventricle is a what? An open space, right? Inside the brain. So where's the hypothalamus set? Right in the midline. See, it sits right there, right there. So we take two brains and we put them together, it's going to set in the midline. So if I take these two brain halves, we're going to say this hand is my right hypothalamus, this hand is my left hypothalamus. We bring them together. Gabby, there's a space in there, isn't there? Okay, bring them together, there's a space. Okay, that space in the midline, if we bring these two halves together, there's a space between the two. That space is the third ventricle, sits in the midline. So when we cut with the little brain knife, we cut them in half, we fold that open, there's no longer a little space in there. I'll show you where that third ventricle is supposed to be. See where this little hole is? If I put the probe in there, that's where the third ventricle is. Okay? There's a little hole there, that's where the third ventricle is down in that space. So here's what we say on the test. Okay, I will give you, we, the TAs, and I will give you a leading question. Because we fold this open, if we put a pin right here and we say, what is this tissue? You say, it's hypothalamus. If we say, what ventricle is located in this space or in this location, we say what? Third ventricle. So if we put a probe right there and we say, what's that tissue? You say hypothalamus. If we say, what ventricle sets here? You would say, third ventricle. 1, 2, 3. There are 4 total. We'll talk about the next one in just a minute. What do we have next? Third ventricle. So we talked about thalamus. We said this is the intermediate mass of the thalamus. The thalamus is right here. Hypothalamus is here. Optic chiasm is right there. Thalamus, hypothalamus, optic chiasm. The next thing you got is what we call the pineal body. Pineal body, pineal gland, same thing. It's involved in producing melatonin if you care. Many of you right now have it surging through your bodies because melatonin helps you sleep. So, pineal gland, remember we talked about the lips? Let's go back to this. Upper lip, lower lip, where they come together at the back. Upper lip, lower lip, where they come together at the back. There should be a little P-shaped, in a human it's P-shaped in size, little structure back here, right below that posterior corner of the mouth. Right there, right below it. Mouth, this is the back corner of the mouth, right below it is where the pineal gland sits. This one's gone, that one's gone, that one's gone, but Jorge grabbed one for me. This is the back, that's where the corner is of the mouth. Right below there is this little, and be very careful because it'll fall off. You can see how it wants to come loose. That's a pineal gland. There it is right there, see it? Corner of the mouth, right below it is a P-shaped structure, that's pineal gland. Okay, do you all see that over there, Chrissy? Okay, on the side. All right, midbrain, we talked about, let's go over one more time. We said midbrain where the cerebral peduncles are, pons right here, medulla oblongata from here to here. And then this is the cord down below. Okay, so always get your bearings first on the brain stem. Remember, brain stem has 3 things. Pons the highest part, midbrain above, medulla oblongata below. Cerebral aqueduct. So an aqueduct carries water from one area to the next. Farmers use aqueducts. They still use them today. So where's the cerebral aqueduct? Well, remember where our third ventricle was located. This one's probably pretty good. Third ventricle, there's the intermediate mass, there's the optic chiasm, third ventricle right there. Okay? Third ventricle in this space. Third ventricle right there, right? Well, it doesn't show the cut, but there's a little groove. You can see it right here. See that little groove right there? See that groove? See that groove right there? Going from basically the thalamus, third ventricle, goes up like this and goes all the way back. This is the cerebral aqueduct, or the mesencephalic aqueduct, or the aqueduct of Sylvius. We'll talk about that in the lecture. All right? There it is. It's going from, it's carrying CSF, cerebral spinal fluid, from the third ventricle through this aqueduct back to the fourth ventricle. So where's the fourth ventricle? The fourth ventricle is at the base of the arbor vitae. See that space right there, that crevice? That's the fourth ventricle. The bottom of the arbor, excuse me, bless you. Bottom of the arbor vitae right there is the fourth ventricle. So we go from lateral ventricle down to third ventricle, aqueduct sylvius to the fourth ventricle. Okay, again, lateral ventricle down to third ventricle, aqueduct sylvius to the fourth ventricle. All right, and then we covered cerebellum, we covered cerebral peduncles, pons, medulla. Any questions? All right, we'll cut you all loose. I don't know which ones went where. Chrissy, do you have gloves on?